Hey everyone, this is IA, and today's video is about IAPC8. We're continuing on the series of explaining the units of this computer, and today's video is about the simplest part of it, or maybe the coolest part of it, that is user output concerning the screen. So this screen is an example of how we can output value from 8 bits from an 8-bit value to something on the screen. And I would like to have something, I wanted to have something that was the highest, the biggest screen I can make with this 8-bit value. But the first thing I went through is that I wanted to have a value that I can split to have the height and the width, but I wanted to have more width than height. So I'm just gonna start a loop here so that you can see it moving. So I wanted to have a screen that is wider, a bit wider than height. But the thing is that with 8-bit value, I had a per number of digits. So if I want to have the highest number of coordinates, I can use 4 bits for x and 4 bits for y. But if I want y to have less bits than x, I can say, okay, I will use 5 bits for x and 3 bits for y. But the thing is that doing this, you will have 2 bits more from in x than in y. And that makes a huge difference. You have a screen that is really flat and long, and that's pretty ugly. So I wanted to have a screen that looks like a standard screen, as we has like 16/9 or yeah, things like that. So I prefer to not use the last bit for this reason. I use it, but in another purpose. I only use the three biggest, the three, how do we say, not biggest, we say the lowest, less significant bit, most significant bit. So the three most significant bits for the height and the four less, but except for this one, the 4 less significant bits for the width. Those are addressing, so we're having a natural binary value on 4 bits and natural binary value on 3 bits to address which width and which height to target. And the last bit says toggle. If it is 1, we toggle the value, so the value is 1. If it is 0, the bit should be back. Actually, this is a toggle bit because with the model I had here, I went to a decision that I can't really control. It was really hard to control just this pixel, put it to 0 or put it to 1. So it was simpler to say just make a pulse. And so I don't know which state this pixel is, but just invert it. So this bit says invert this this value, actually making a proper coordinate here with 0 here makes nothing to screen. That's a bit sad of it, but yeah. At first I wanted to have this bit pretty useful, but for the moment it is just a pulse. So we must send a pulse, and yeah, this is it. This screen, I prefer telling you that you've seen that it worked perfectly, but when I loaded the map, each time I start the game and load the map, the first line has a bug that those pistons here, you saw that pixels are on 4 blocks. The pistons here, so 1 pixel over 2 here on the first line only, on the upper line only, they are like stuck. The second pulse is just stuck in the wires. I don't know where exactly, but it did not come over there, and so 1 pixel/2 on the top line is stuck. The only way to fix it is to just, when you're starting your loading your chunks here, you just enable the whole line, you place back the redstone blocks, and then you're done. Sorry. So this is it. This is it for the screen. I'll just cut the loop. Yeah, have an interesting value. So for addressing, we have 3 bits here for the height, and depending on the height, will enable one floor, one ring, or another, and those rings concerns the size here. So here we have lots of compact AND gates that says if the ring is okay, and so the height is okay, and you have the correct line down here, because here we have the X split, the X selection, you have the correct line here. So if you have the correct line here and the correct ring, the pulse will go through the correct wire. And so the correct wire will then here create a pulse. So this is a pulse, a 1-tick pulse, and this is made using this. So outputting one thing here. This double inverter is just to have like a repeater this way, but not to have that much of repeaters. I use torches, because actually those repeaters are not really instant, but yeah. So here's a pulse, 1-tick difference, and or a little tiny bit of 1-tick of difference, but yeah. And here just powering those pistons independently using blocks without making buds with pistons down, and that's it. I think this is it. What should I say more? The only complex thing here, if we can say that it is complex, is the separation here. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 values, which is normal because we have 3 bits for our height value. So we have 2 power 3, which makes 8. So we have a selection of 8 values. Selection that is made here at this floor. So first bit, second bit here, and third bit here. Result is outputting here. So you have a selection, and the selection for the X coordinates is just upwards, just here, just on top of the Y here. We have the X here, which are 16 coordinates. So we have 16 possibilities. And here we have 1 selected here, and 1 selected here. So we have 2. Yeah, on the one side that is on. So here we may have an additional cut here. This one is off. Yeah. Okay, but we have 1 bit here. Yeah. This is a little bit tricky because I have 1 bit here that goes downwards, so we can't really see it. If we're just seeing this torch, we say, okay, this is fine. This one is selected, but actually this one is selected and the other one there is selected. But because I had the line down here, this cuts the value by outputting something here. If I'm cutting this, I have 2 values outputting. So this is an additional bit to bring a bit of compactness, so that we can address 16 bits, 16 values with only 4 bits, And so this is it for this video. I don't think I have something else to add. Yeah, no, I don't have really something else to add. Yeah. So I hope you enjoyed this video. And I think the next video will be about data, and actually finally the last one will be on programming and making assembly code, compiling it to load it to our computer. So that's it. That was IA Let's Code.